Okay, in today's video, we are going to be solving for an angle in a right triangle. This is the last lesson for our trig unit. This is when we are going to be using the inverse of the trigonometric functions. Now, many of you are using your calculator to calculate the trig functions. You're still going to need to turn your phone sideways to reveal the trig functions. However, for those of you using iPhones, we'll have to or Androids, you will have to make sure that you are in degree mode. So make sure that the RAD is not on the upper left-hand corner of your iPhone or your Android. It's not visible. If you do see that, please hit the DEG button. It should be the lower left-hand corner. Then you're going to want to hit the second button. Okay, it's a button that just has the word second in it, and it will reveal the trig. Sine, cosine, and tangent will turn into sine to the -1, cosine to the -1, and tangent to the -1, just like we see here. The word inverse means to perform the opposite. In trig, we need to do the same thing. The inverse trig functions do the opposite of their regular trig functions. So the inverse of sine is sine to the -1, does the opposite of sine, and so on and so forth. If you know the trig ratios but not the angle, then you can use the corresponding inverse trig function to find that angle. And here's what they are. So remember, sine is opposite over hypotenuse. The inverse is sine to the -1 times the opposite over hypotenuse, which would give you the angle measure. Before we were taking the sine of an angle, remember we replaced theta. This is called theta right here, this 0 with a line through it, if we don't know the angle measure. So now, let's go over this problem here, model problem. You can go ahead and with the steps follow along and use your calculator. We're going to find the missing angle measure of this triangle here. There's a line LV. We don't know what this corner is here because that's the right triangle. Remember, your hypotenuse is always opposite that right triangle. To do this, we want to do the same thing we were doing last with solving for a side of a right triangle. We want to identify what the two known sides mean to this missing angle. So this angle here, we have the opposite side. This blue side is our opposite over our adjacent side. Because remember, this is the hypotenuse. It's opposite the right angle. So opposite and adjacent. When we're remembering our SOHCAHTOA, opposite and adjacent deals with tangent. So we want to find the tangent, the inverse of tangent of opposite, which is 35 over 65. So now what's good here, if you have an iPhone and you're using an iPhone, you need to plug in 35 divided by 65, hit equals, and then hit the tangent to the -1 button. If you're using an Android, most Androids, you can hit tangent to the -1. It will come up with a parentheses, and you can type in the 35 divided by 65, and it will work out for you. So tangent of 35 divided by 65 ends up being 28.300755. Remember, we always went around to the nearest hundredth, so approximately 28.30 degrees is our answer. That's our angle measure for angle L. Take a minute, pause the video, and work on your check for understanding, which is on the next page. Okay, so the next page, our check for understanding, I put your steps there as well. And we are going to find the missing angle measure of angle I. Now we have to look to see what these two sides are in accordance to this angle. So we have our opposite over hypotenuse, which is sine. So we have the sine to the -1 of 8 over 10. Plug that into your calculator. Okay, using your phone, remember 8 divided by 10 first, hit equal sign, and then sign to the -1 if you're using a iPhone. We are approximately 53.13 degrees. Okay, actually there's a 0, 1, but we want to round to the nearest hundredth. So for the iPhone, remember, you want to place the 8 divided by 10, hit equals, and then automatically go to the sign to the -1, which remember you get that when you hit the second button. And this is how we find the missing angle of a right triangle.